Yes, yesterday we had started with wave optics, and Heinz principle we had completed, and interference we had started. So in interference, we had seen the phase difference. Phase difference was represented by phi, and the path difference between the waves, that was represented by x. So a relation also we had seen, phi naught by 2 pi is equal to x by lambda. Then superposition principle, that is, you will, when all the waves will be superimposing each other, this is how the resultant of the displacement will be given. Now starting with coherent sources, and the same thing about non-coherent sources. See, if this is one source which is emitting one wave, this is another source, this is emitting one more wave. When both are emitting two waves, if the wavelength is also same of both the waves, the frequency is also same both the phase, and a phase difference is fixed. For example, if I say phase difference between them is pi, that is 180 degree. This is constant. This is not changing when the wave is propagating. So it means these two sources, S1 and S2, we will say they are coherent sources. If phi becomes variable, automatically these two will become non-coherent sources. So sources emitting light waves of same frequency, same wavelength, and a constant phase difference. Three things. See, just remember three things. Same frequency, same wavelengths, and constant phase difference. This is what is meant by coherent sources. All right. Now, what was interference? Interference definition wasn't written yesterday. So superposition of waves from two coherent sources, phenomena of redistribution of light energy due to superposition of light waves from two coherent sources is interference. So the second definition you will be writing in your exam, because this is a better definition. But what you have to remember is that if two sources are coherent and the waves are getting superimposed like this is called as interference, which we had started yesterday. So I'll start with Young's double slit experiment. Quickly write it down. Now starting with Young's double slit experiment. So basically in Young's double slit experiment, this is a piece of, separation that is taken, and on both the sides, one here and one here, two slits are formed. Very minute slits are formed. S1, S2, these are the slits, and the separation between the slits is small d. Remember, this variable will stay with you throughout. Now there is a main source. This main source, this is producing the waves. From here, the waves are coming, and entering into the slits. Now from the slits also, these waves are moving. From here also, from both the slits it is moving. This is one, this is second. At a certain separation, a screen has been taken. This is the screen. So what is observed and what you will also observe is, see, some bright light you will be observing. On the center of the screen or on the corners of the screen, you will be observing one very bright accumulation due to the superimposition. What happened is, this wave from the first slit and the second wave from the second slit both have superimposed on each other, and they result into fringes. We call these blocks that are formed, these blocks, these are called as the fringes. So this is a very bright fringe, right? All these are called fringes, so we call this as a bright fringe. And if the same thing has been formed like this is known as a dark fringe. So this is dark fringe. So what happens is, in the center of the screen, see, you get a very bright screen, which is known as the central maxima. Then you get the first dark on both the sides. Then you get again first bright on both the sides. Like this. I'll show you this. See. Like this. See. You get a very centrally bright fringe. This is known as the central bright fringe on the screen. Then the space where you do not see any fringe, this is the first dark fringe that has been formed. Because there is no light, the superimposition of waves didn't occur. Superimposition of waves and how they are interfering. This is because, see, when both the troughs of the waves, they are coinciding, they are superimposing, so you get a higher amplitude increases, so because of that you get a very bright fringe. And when they are opposite, like crest of one and trough of one, like this, here both should be same, either trough or crest, both can superimpose. If even one is opposite, it will decrease. We will see by mathematical calculations also, we will see how this is possible. So you get first dark here on both the sides. Then you get the first bright. This is not the first bright. This is called as the central bright fringe or central maximum. So these are the first bright fringes. Then second dark fringes. Then second bright fringes. Again, third dark fringes, third bright fringes. Like so, like this entire interference will keep on occurring. So this is what you have to remember. So let's say y1 is a sine omega t, y2 is b sine omega t plus phi. If you remember, I told you amplitude is directly proportional to square of intensity is directly proportional to square of amplitude. Phase difference is phi. So I1 will be Ka square, I2 will be Kb square. This we'll see later. First, let us see this part. Y1 plus Y2 when the superposition principle is taking place. Y1 is equal to Y2. This yesterday only I told you that this is through the superposition principle. So Y1 is A sine omega t plus Y2 is B sine omega t plus phi. Now see, Y is A sine omega t plus B sine omega t cos phi plus cos omega t sine phi. We have used an identity over here for this. Sine A plus B is equal to sine A cos B plus cos B sine. So same identity we have used over here. So A sine omega t. Now this B is being multiplied to this bracket and to this bracket like this. So what we get? We will get A sine omega t plus B sine omega t cos phi plus B cos omega t sine phi. Now, class, one thing. If we take something common from here, see sine omega t is present, here sine omega t is present. So I can take sine omega t common, correct? So I can write this as sine omega t. What am I left with? A plus B cos phi. Correct. And what am I left with here? P cos omega t sine phi. Now class, look. Or let me rearrange this. Let me write sine phi first. B sine phi cos omega t. Look here. A plus B cos theta. This term. A plus B cos theta, cos phi is written as R cos theta. All right. This is one equation as the resultant cos theta. This we are writing because this is like a single angle. This will I'll tell you later. And this B sine phi, this is written as R sine theta, second one. So now, if I say R is the amplitude of the resultant wave, this R which I'm writing, and theta is the phase constant of the resultant wave. Theta is the phase constant, R is the amplitude. Now, how will the final answer be? Y is equal to sine omega t R cos theta instead of that entire term, plus this is R sine theta cos omega t. Now, I am taking resultant as common. So, R has been taken common, sine omega t cos theta plus sine theta cos omega t. Again, the same identity will be used. Y is equal to R sine omega t plus theta. This is the resultant of amplitude. Both the amplitudes. One way, y1 will be having its own amplitude, y2 will be having its own amplitude. This is the resultant of the amplitude. How will we find this? R, you can further find it by a square, that is amplitude of first equation, b square, amplitude of second equation, plus 2ab cos phi. Using your simple parallelogram, this is one formula. This is the equation of resultant amplitude. This is, if don't be confused, this is the equation of resultant wave. Equation of resultant wave. This is the entire waves equation. When we are specifically finding it out for resultant, this will be it. And similarly, in parallelogram law, the way you write tan theta, this is equal to b sine phi divided by a plus b cos phi. This you can use for finding out the value of theta. All right, this is how you will use it. So small derivation, but important is this. Very small derivation, this you can write it down. Let me know any doubts you're having from Young's double slit experiment.
Ma'am, what is y?
Resultant displacement along y-axis of the wave. See, intensity of the resultant wave. So I told you, 2 points. That intensity is directly proportional to the square of the amplitude. So for resultant wave, see, individual waves we have seen. See, I1 is equal to Ka square, I2 is equal to Kb square. But these are the individual one. Now we are talking about the resultant wave, the after the superimposition of the two waves that have been produced. So I resultant will be Kr square. So resultant square, I have put the formula of resultant. This was only the equation of resultant, under root a square plus b square plus 2ab cos theta. Its whole square, this is equal to a square plus b square plus 2ab cos theta. Let's multiply k with every term. So equation of the resultant will be Ka square plus Kb square plus 2Kab cos theta. 2Kab cos theta cos phi. Now, one thing, class. For Ka square is written as I1 square. This Ka square, this is written as not I1 square, only I1. So I1 is equal to Ka square. Remember, in the starting only of the class, I told you that I1 is the Ka square intensity of the first equation. Similarly, Kb square is I2. That is the intensity of the second equation, Kb square. And one more thing, class. If I write root k into root k, that will be k. So I am separating this k. Now look, what is the final resultant value? I1 is Ka square, I2 is Kb square, correct? If I take the root, it will be root I1 is equal to k root Ka, correct? Here also root I2 will be equal to root k into b, because b square is there, a square is there. Now I resultant is Ka square plus Kb square plus, now look, this is 2Kab, correct? This is 2Kab. K I am writing it as under root k into under root k. Root k into root k will give you k. So this k I am writing it as root k into root k. So this will be 2 root k into root k into a into b into cos phi. Now look how will we write the final intensities formula. I resultant is, what is ka square? Ka square is I1. So this is I1 plus, what is kb square? I2 plus 2. What is root k into a? Root k into a is root I1. What is root k into b? Root under root k into b is under root I2 and this cos phi. So this is the equation of the resultant equation. First tell me, any doubts still here? It's
No,
clear?
ma'am. Yes, ma'am.
All right. So this is the intensity of the resultant equation. The way you have the intensity resultant wave equation for amplitude, this is for the intensity. All right, now we'll see some conditions. But before the conditions you write, the condition of maxima and minima, I'll tell you. That is, when will you get bright fringes, when will you get the dark fringes. Quickly write down this intensity portion. It's small. Okay, class. Now starting with the conditions. So conditions of minima. Minima means destructive interference. Destructive interference means when one crest and one trough, they are coinciding. This gives you minima, that is dark fringes are obtained. So this is the condition of R minimum, where your cos phi will be equal to -1. So phi will be, for getting -1, you have pi, 180 degrees also -1. You have 3 pi, cos 3 pi is also -1. 5 pi, and so like this. So you can remember it as 2n minus 1 pi. So how can you remember phi for destructive interference, that is dark fringes? 2n minus pi. This is the phase difference for it. And I already told you a relation between phase difference and the path difference. So phi by 2 pi is equal to x by lambda. So from here phi is 2n minus 1 into pi by 2 pi is equal to x by lambda. Pi will be cancelled. So x is equal to 2n minus 1 lambda by 2. This is the path difference. So this is the phase difference. This is the path difference between the two waves. All right. So even when you will put it cos phi as -1, this will be under root a square plus b square minus 2ab. That makes the equation. This is equal to under root a minus b whole square, which is equal to a minus b. So in minimum intensity also, we will be using minimum square. Everything will be used for the minimum one. So I minimum will also be k a minus b whole square, like this. Understood? This is the condition for the minimum one. Write it down first.
Ma'am, is that sigma by 2 pi or 6 by 2 pi?
Which one? Which one? This?
No, ma'am. It's
Oh, this is
it's
5. This is 5.
Ma'am, that is also 5 by 2 pi.
Which one?
The above one you have cut it. 5 by 2 pi or
5 by 2 pi is equal to x by lambda.
okay.
Second is condition of maxima. You can say dark, bright fringes. This is condition of maxima or bright fringes or constructive interference. So in this slight difference will come that this has to be positive for our maximum. This has to be positive +1. So the formula is a little different. You start with 0. Cos 0 degree is equal to 1, then 2 pi, 4 pi, like this till 2n pi. So this is equal to 2n pi. This is the phase difference. So here also, this is 2n pi. This will be, there will be a difference in the formula. This is 2n pi. So 2 will also be cancelled. X is equal to n lambda. This is the path difference. So when we'll put 1, this will be +1. This will be plus. And this will also be plus. Here this will be maximum. Quickly write it down. Now this you only have to copy it quickly because the portion before this. And what was constructive interference? Meaning of constructive interference. Constructive interference means when both the waves are present, their crest and crest are coinciding, or both the waves have their trough coinciding. This is constructive. If opposite, then destructive. Write it down quickly. This part, write it very quickly. See, this question says that amplitudes are given, A is given and 2A is given. You have to calculate the ratio of the intensities. So I1 will be Ka square, I2 will be K, this is 2A. So this becomes 4A square. So when we'll take the ratio of both of these, I1 by I2, this is Ka square by K, 4A square. So this will be cancelled. So I1 by I2 ratio will be 1:4. Second part says amplitude of resultant wave if phase difference is pi by 2. This is the first part. Second part, phase difference is given as pi by 2. And you have to find out the amplitude of resultant wave. See, R is equal to under root A square plus B square plus 2AB cos phi. Since this is 90 degree, this entire term will be 0. So resultant will be under root A square plus 2A whole square. That is, this is 4A square plus 1, 5A square. So resultant will be A root 5. Third part says resultant if path difference is lambda by 2. See, x is equal to lambda by 2. So we have to find out what is the phase difference. Pi by 2 pi is equal to x by lambda. So x will be equal to, or directly if we put x by lambda is equal to, this is lambda by 2. X is lambda by 2, phi by 2 pi. This gets cancelled. Phi is equal to pi. Simple equation resultant is A minus B. That is, you have 2A and the other one is A. So 2A minus A is equal to A. This is the answer. Quickly write it down. Then we'll see some other portions. Okay, class. So we'll meet after 1 hour in your next class. That will be a little longer class. We'll not just have 1.5 hour class. Big portion I have to complete.